Okay, again, a series of 5 questions, looking over them, make a decision about which one looks the easiest, which one looks the toughest. Sometimes they're deceptive. I want to point out that number one looks fairly easy to do. It says, can the sum of two prime numbers be prime? Well, let's take a look. You don't know the answer to that. Let's just write down what you might write down. Let's just write down what the prime numbers would look like. Just give me 1 second here. So the prime numbers, set of numbers, one's not prime, but two is. Let's see, 3 is prime, and the next prime would be 5, and then not 6, but 7, right? And the bottom line is, it says, can the sum of two prime numbers be prime? Well, let's write this down. 2's prime, and 3's prime, and if I add those together, I get 5. So the answer is yes. Right? I found an example where the answer is yes. All right, number 2 is the perimeters of two concentric circles. Oh, let me look at the answer. Yes, nothing more to say. That's so true. So I'm going to get my eraser out, like I was at the blackboard, and I'll erase this work over here. Now, granted, I got to make a decision about number 2. Is it going to be easy to do, or am I confused by what I've read? And you make these decisions as you're going through a competitive exam. All right. Remember, other people are also doing the same thing, and they're trying to maximize their points. Some competitive exams have incredibly low scores because the exam questions are incredibly difficult, and they got to sift through the work to find out who does the best work as well. All right. So let's take a look. The perimeters of two concentric circles are in a ratio 2 to 3. So I want to draw my little hokey picture of two concentric circles, like this over here, and then there's another circle over here. All right. Now, granted, I didn't do a very good job, but they both share the same center. All right, with the understanding that there's a radius of the small one, looks like this, coming from this, and a radius of the big one that looks like this over here. All right, so I'm going to say the radius of the big one, the big circle, its radius I'll call R2, and the small one, I'll call its radius R1. All right, so it says perimeter of two concentric circles. Let me write perimeter down now. So the perimeter of the big circle, the big guy, its perimeter is actually just, you know what, instead of putting B down, I'll say big, right? Why be cheap with the ink? So big. Its circumference, C, I'll call it CB, is going to be, you know what, let's call it C2 because I'm using that notation. So let's call it C2 instead. This is the big guy. And what's it going to be? Pi. Circumference is 2 pi r, right? So 2 pi r2. Then the small guy's circumference, I'll call that C1. And what's that guy going to be? It's going to be 2 pi r1. By the way, the reason I'm using uppercase R is my lowercase r is really hard to differentiate between that and the letter V. That's why I use an uppercase R for radius. All right, so again, I want to make sure I understand what they said. The perimeters of these two concentric circles are in a ratio 2 to 3. Well, 2 to 3. So what does that mean? It means if it's in a ratio of 2 to 3, that means it's going to be the small guy, 2 pi r1, over the big guy, 2 pi r2, would be in the ratio 2 to 3. All right, let me simplify that. And what do I see? I see 3 R1s would be identical to 2 R2. Let me just briefly go through that for you. The 2's are canceling off, the pi's are canceling off. Then I multiply both sides by 3R2, and what I'd get is 3R1 equals 2R2s, all right? Now, I'm going to say that's important to me because I found a relationship between the radiuses at this point, all right? So let's keep moving on. Again, R2 is the big radius and R1 is a small radius. It says over here, the two radii making an angle of 60 degrees. So the two radii make an angle of 60 degrees, intercept the portion of the circular ring equal, well, I want to point out what the circular ring is. The circular ring This is the circular ring over here. So they're saying now that these radii would intercept a circular ring. So they're talking about this region over here where it intersects it. All right? And what's the angle over there? The angle's 60 degrees, right? Let's write this down. And remember, you got to be in the radian mode, so that's going to be pi over 180 degrees, which could be pi over 3. All right, so it said the two radii making an angle of 6 degrees intercept the portion of the circular ring equaling an area of 120 degrees. I'm sorry, 120 square inches. So this guy over here is 120 square inches, and I got to figure out that now. So let's put that down. So 120, well, that's going to equal the big sector. And the area of the big sector is going to be 1/2 theta. Well, theta is pi. Let me put this down. Area of a sector is 1/2 theta r squared. And you learned that in trig. Right, so 1/2, the theta is pi over 3. And the big radius is going to be, let's see, that's going to be big R, the second one, squared. Now, I got to take away the small sector. And what I mean by that, this small guy over here, I got to take that away. And what's the small sector going to be? 1/2, I want to get the ring now. This is going to be the ring. So 1/2, the theta is still pi over 3, and its radius is R1. All right? I don't even know what their question is, but they say find the radii of the circles. Wow, that might be tough to do. So let's take a look at this, and I'm going to go through it slowly. 120 equals, it looks like I can factor out a pi over 6. And what would you be left off with? R2 squared minus R1 squared. Well, I got two unknowns. I'm going to keep writing this thing, and I don't know, I guess I could write down like 6 times 120 over pi, right? Equals R2 squared minus R1 squared. And I'm still back in that. And I want to point out that this may be useful to get one of the letters to disappear. And I'm going to say that R1, let me write this on the side for you, R1 is just really 2/3 of R2. Let me write that down for you. So 6 times 120 over pi is going to be R2 squared minus R1 squared. Well, I'm looking at this over here. And what's that going to be? 4/9. I'm squaring that number. R2 squared. All right, let me keep going. Let me make sure I did this right. I'm going to keep reading it. 2 to 3. I think I did that. 2 to 3. 2 radian making an angle 60. 60 is pi over 3. The ring's 120. I'm just looking over my work. And let's keep writing this down. So what do you get? 6 times 120 over pi. And then what do you get? Well, let's see. You would get 9/9 minus 4/9 is 5/9, right? I'm hoping these numbers are going to work out nice for me. So I would see 6 times 9 times 120 over 5 pi would equal R2 squared. So let's take a look at this. I know 5 goes into 120 24 times. Yeah. And let's see what we get over here. I don't know if I want to multiply that out. I'm going to write this down now because I'm looking for something easy to do. 6 times 9 times 6 times 4 over pi. Now someone says, why would you do that? Because I'm looking for something that's easy to do arithmetic-wise. And I think I see it now, although I could be making a mistake. So I'm going to say, I know R is positive, by the way. So I know this is root pi here. I'm not going to do plus or minus, by the way. It's going to be 6 because I see the 6 squared. The square root of 9 is 3, and the square root of 2, I'm sorry, square root of 4 is 2. So you're going to get, lo and behold, it's 36. That's pretty easy. All right, so I know what R2 is. Let's write this down. I know R2 is going to be 36 over pi. What's R1? Let me make sure I'm answering the right question, by the way. Find the radii. I did. I found one radius. Could do the other one. And I think, though, the other one's going to be 2/3. And again, I'm using this formula over here, times 36 over pi. And what do you get over there? 24. All right, so I hope you realize I did answer the question. The question is, did I get it right? Well, I do see this, and I see this too. Yeah, we're doing all right. All right, let me get my eraser out. Again, it's like I'm at a whiteboard or a blackboard. I'm moving on to another problem now. You can always pause the tape and come back to it. But again, I'm just practicing, so when I get to a competitive exam, I have better chances of doing well on it. It would really be great if you got a competitive exam where all the questions were, the ones you've seen before. And that would be great. See, it does happen, by the way. That's why it's really tough to make competitive exams now. Some people practice endlessly. They go to YouTube. They keep watching videos of novel problems. All right, so I'm going to say I did number 1. I did number 2. Number 3 looks like a nightmare. Number 4 looks manageable. And number 5 looks manageable to me. I'm going to say there's many ways to do number 5. Now, I'm going to look at number 5, and I'm thinking an inequality looks pretty easy to do. And one thing I know about this inequality, I know this. I know x squared plus 1 is always a positive number in a real number system. All right? So what I'm going to do is I'm just going to multiply all the sides by that. And I want to point out what I get. It's really not that bad of a multiplication. It's going to be, let's do the left side. I'm multiplying all sides by this. I know the middle guy becomes 1 when I do that. But let's talk about the other sides. And what do you get? You get 1 times the left side, which is 1 minus x squared plus x4 minus x6. And then I have to do x squared times that side. What do you get? X squared minus x4. Again, I'm going slowly over here. Plus x6 minus x8. And if I were to simplify that, what would I get? I get 1. An awful lot of things cancel off, don't they? So boom, boom, boom. I get 1 minus x8. Well, that was convenient. Let me do the other side. It's going to be, x squared plus 1 times that. I'll do 1 first. It's going to be 1 minus x squared plus x4 minus x6 plus x8. Now I'm going to multiply by x squared. You get x squared minus x4. Let's see, plus x6 minus x8 plus x10. And if I did that, what would I get? A lot of things cancel off, don't they? So 1, and then I get plus x10. All right, I'm getting a little better at this point. What am I going to do now? I'm going to subtract 1 from all sides. I want to get minus x8, 0, and x10. All right, I hope that you can solve this by inspection now. But if not, you got some work to do. Sign analysis, all that kind of stuff. But I'm looking at it, and this is true for all x. True for all x. So x can be any, sorry about that. X can be any real number. Or if you want to write down x can be any real number on the interval between minus infinity to infinity. Okay? So let's take a look at the key, see how they did it. That's 5, right? Well, they did it a little bit differently. So, same conclusion in the end, but they did it differently. I want to tell you how they did it. They did it by division. And I know that looks difficult to you, but I want to go through that with you. So they divided this guy over here, and when they do that, it looks like this over here. I'm going to write this down as, 1 plus x squared, and I'm dividing it into 1. And that would be 1. You'd get 1 plus x squared. And then what do you subtract? You get minus x squared. So then what do you get? Minus x squared. That would give you minus x squared minus x4. And I think you probably get the pattern up here. This would be x4. Then what you do, plus x4. And what do you go over there? I'm running into work here, but I'll write this down for you. You get x4 plus x6. You would subtract to get minus x6. So I hope you realize you keep doing this. I'll keep writing it down. And then you get minus x6. And then you get minus x6 minus x8. And then what do you have there? x8. And again, I hate to do this, but you'd have to do this yourself if you were doing it this way. I definitely see the pattern, by the way. But someone says, could you do this forever? I want to point out, no, you can't do it forever. And the reason for that, it would only converge for certain x's. So I'm not going to do that. I'm just going to stop at some point and then put down the remainder. And let's put this down. So x8. And what do you have there? You get x8, let's see, plus x10, right? And then if I subtract that, I get minus x to the 10th power. So I'm going to write this over here, that if I did this by long division, just initially I get this over here. And again, I'm just going through what they did in the K. It can be done differently. A grader would have to make a decision which is better. And that's really kind of, arbitrary. And I get a remainder of x10, right? Over 1 plus x squared. Now, someone says, why would you have done that? Well, to solve the inequality. And certainly doing it, I think I did it in 2 different ways. I did it with the x8 and the x10. Both of them are written down for you. And solving, sort of like an inequality there. All right? Actually, I think the way I did it initially was better. I do. But there's nothing wrong with this. It certainly flows. Division was tough, though. All right? Let me keep going back to the problem set. And I'm looking at it. And again, what I'm looking at, you may disagree. I thought 1 was incredibly easy. 2 wasn't that bad. 5 I just completed. I don't think that 5 was that bad either, at least by the method I just showed you here. Maybe by long division it would have been difficult, but kind of like what I did over here better. All right, I can't say one's better than the other, though. Do not think I'm making a judgment on saying one is better than the other. Just wouldn't do that. Let me just erase all my doohickeys over here. And I'm going to go to another problem. And I got to make a decision here. So what am I left off with? I'm left off with 3, and I'm left off with 4. Now, again, 3 looks tough. All right, I'm not saying it is. I'm saying it looks tough to me. I could be deceived. It might be really simple. But I'm going to say, a woman tripled the number of sheep in her pasture. So I'm going to say S equals the number of sheep. Whoops. All right, and then it also talks about number of cows. So I'm going to say C is the number of cows. So it says a woman. By the way, the understanding here is that S and C are integers, and they've got to be positive numbers, like 1 sheep, 2 sheep, 3 sheep, 1 cow, 2 cow, 3 cow, so forth and so on. So it says a woman tripled the number of sheep in her pasture. So what does that mean? Now there's 3S. She tripled them. I don't know how she did it, but she tripled them. And then what she did, she sold 4 sheep. All right? So I'm going to say she had, S sheep, she tripled them and then sold 4 of them. So this is how many sheep she now has. Okay? And then it says, in their place, she added, right? So a woman tripled the number of sheep in her pasture and afterwards sold 4 sheep. In their place, right, added 3 more cows to her pasture. So how many cows they got? The cows would be cows plus 3. The number of sheep and cows in her pasture totaled 15. Okay, so now if I add these together, I'll write this down. This is the number of sheep plus the number of cows. Now it says, now it's the then part, totals 15. All right, I'm going to simplify a little tiny bit. And what would you get over there? You would get 3s plus c minus 1 equals 15. So let's write this down. 3s, maybe that doesn't look very good, does it? Let me erase that. So 3s plus c equals 16. All right, here comes the tough part. How many of each were there at first? Determine all possible solutions to the problem. All right, so I got to think about this. And this is the problem. If thinking takes a lot of time, then you want to move on to another question. All right? But let's take a look at it. A woman tripled the number of sheep in her pasture, and afterward falls short sheep. So let's say, I don't know, let's say she started with 1 sheep. This is what she started with. S equals 1. Now, if she tripled it, she get 3, but she couldn't have sold 4. All right? So a woman tripled the number of sheep in her pastures and afterward sold 4 sheep. That couldn't happen. So let's go to S equals 2. So a woman tripled the number of sheep in her pasture and sold 4 sheep. And she could do that. So if she did that, well, what would she get? So it would be, if she tripled, it would be 6, and then she sold 4, she'd be left with 2. Okay, and in their place, they added 3 to the number of cows in her pasture. All right, let's write this down. So if I say S is 2, how many cows would there be? Look at it over here. So if the S is the original number of sheep, you'd have 3 times 2 is 6, 6 plus 10. All right? Let's keep going. S equals 3. All right, let's take a look at that. A woman tripled the number of sheep in her pasture. That means she has 9 now and sold 4. Well, she could do that. All right, let's write that down now. So what do you get? 3s, that would be 9, and so C would be 7. Let's do S equals 4. So a woman tripled, that would be 12, and sold 4. She could do that. Now, if she did that, what she have? She have 12, so C would have to be 4 now. By the way, we're looking at this to do that. Let's do S equals 5. And what do you get? You tripled them, you can sit myself 4. That would be 15. C would be 1, right? I think we're at the end. And why is that? If I want to a bigger S, my C would be negative. So I'm going to say these are my possibilities. 2 sheep, initially anyway, 10 cows, 3 sheep, 7 cows, 4 and 4, 5 and 1. All right? Now, granted, I got to repeat this over and over again. Sometimes just you make mistakes. And I'm going to look at the key and see how well we did. Yeah, I didn't consider the 0 sheep because that doesn't make any sense at all because she said she had sheep. So 1 in 13 cows. Again, not possible. So they said these are the possibilities. 2, 3, 4, and 5. So the order pairs that came up was, 2 and 10. See if I put that down. Yep. 3, 7, 4, 4, 5, 1. Uh, 3, 7, 4, 4, 5, 1. Yeah, I got them all. All right, we did all right. Let's keep going. So let's not go too fast, right? That's an older problem set. I want to go back there. Let me get my eraser out. It's almost like I was at a blackboard, and I'm sure your teachers erase their blackboard after they're done something. A lot of times, people, especially in big universities, they have these multiple boards, and they kind of just rotate them up. you know what I'm going to do for this one over here? I want to walk you through it. All right, I'm going to walk you through it with nicely neat typed up work for you. So what did we do so far? We did 1. That was easy. We did 2. That wasn't so bad, by the way. 4 wasn't so bad. And really 5 wasn't so bad. I'm going to say they're, for the most part, confidence builders. But 3 could be a confidence destroyer. All right? You could start the wrong way. You could do all kinds of weird stuff with it. But I want to go through the way that I started it and the way I finished it. All right? I want to point out, just looking at it, I do know that A is a positive number. And in knowing that if A is a positive number, what I know about this is, X has also got to be, let's see what X has to be greater than minus A. And Y has to be greater than A. I know that much. Now look at the second, I'm just looking at the first line. The second one, X has to be greater than A. I'm looking for a kind of restriction. By the way, A is positive. And, Y's got to be greater than minus A. Well, my restrictions over here, looking at all my restrictions over here, I'm saying this has to be the case. All right? For that to be working out for me. All right? So let me just go to the work. Again, I'm kind of just futzing around initially looking at it. But I still don't know what X and Y are by looking at that. So I got to I get busy working. So I want to go to the actual answer key for you. I would recommend you work it yourself first. And I want to tell you what I did initially. I looked at it, and I did what your teachers probably told you to do in basic algebra, isolate a radical. So over here, looking, what I mean by that, I'm looking at this first line over here. I'd isolate a radical, and the radical isolated is this one over here. Someone says, why is that? It just looks easier for me to do that by adding the root of y minus a to both sides. And then what your teacher told you to do in more basic courses is square both sides to remove the radical. It looks tough, though, to do that, but the left side's really simple to do, right? And I hope when you do that, you get this over here. The right side's not that bad to do. I just want to go through it with you briefly. So it's 5 halves root a plus root y minus a squared. I'm squaring it. Well, the first term gets squared. That'll be 25 quarters a. The last term would get squared. What's it going to be? Y minus a. And then what do you get? You get something in the middle. And what you're going to get in the middle is you can get 2 of those things, and these things look like this over here. All right? Now, I realize that looks really strange, but I got to write that down more neatly than that. So what am I going to get? I'm definitely getting the 25 quarters of an A. I'm definitely getting y minus a. And this over here simplifies pretty nicely because the 2 disappears. And you're left off with this thing over here. All right? Again, this could be a dead end. And it happens sometimes. You do a lot of work, it's a dead end. Let's keep looking at it. I'll erase this over here, and I'll tell you what I did next. Looks like what I did next, I added the A's together, right? And it looks like I also took away, let's see, let me just point all the A's to you. There's an A here, there's a term with A in there, an A over there. So let me write down what I'm looking at. I'm looking at 25 quarters. We're talking about the A's now, minus 4 quarters. And then I take another A away, another 4 quarters. And that's going to be what? 17 quarters, right? Because, 25 minus 4 is 21. Minus 4 is 17 quarters. So I see that. I understand that. And I get this over here. And you know what? At least, X, I know what it is in terms of A's and Y's. And I want to do the same thing with the other one. Right, there's 2 equations. So I did the first one. Now I want to do the second one. Let me get my eraser out. And we're going to talk about this guy over here. And again, I'm going to do what your teacher told you to do in, basic algebra, isolate a radical. So the radical I isolated was this one here, and I get this over here. Now I'm getting a little more experience in the squaring department, so I think I could probably square this thing out, but I'll go slowly with you. And what do you get over here when I square that? The right side, whoops, sorry about that. The right side's the left side's really easy to square. It's the right side that gets to be so much trouble. So I'm squaring this side over here, all right? Let me outline it for you. We're squaring this side here. Well, if I were to square that, what would I get? I would get 9 quarters. Whoops, I didn't write 9 there, did I? 9 quarters of an a plus y plus a plus 2 times 3/2 root a root y plus a. All right? So, I wrote that down for you, and that's right over here. So 9, I see the 9 quarters a, I see the y, I see the a, and those 2's cancel off, so I get 3 root a, root y plus a. So I'm seeing that. All right, let me erase this over here. I'm just going line by line. That's what you want to do when you study. Look at somebody else's work, especially when you don't understand how they did it. You look at their work and try to understand what they're doing. All right, so then what I'm going to do, I'm going to try to get the, solve for x, get all the a's on one side. I'm sorry, everything else on the other side. And how do I do that? I'll collect the a's. And you get 9 quarters. I'm collecting the a's, by the way. Plus 4 quarters. And this is going to be adding a to both sides, another 4 quarters. So you get 17 quarters. All right? Plus y, plus 3 root a, root y plus a. So things are looking pretty good. But again, it could be a dead end. And that's the problem with work. Work sometimes is a dead end. And if it's a dead end, it's a dead end. But what do I now notice? I notice I have x equals up here, this, and I have x equals this. So what I'd do is I'd equate those two equations, right? X is x, right? So I equate them over here. And I notice something really simple now. Now, I'll tell you what I'm noticing, like right from the get-go, that these are just disappearing. Let me write this down for you. That these are disappearing when it's subtracted from both sides, and these are disappearing when it's subtracted from both sides. So I'm left with something pretty simple. All right? So let me get my eraser out again. I'm just going line by line. Going line by line, making sure I understand my lines. And I'm on this line right over here now. And what I would do there probably is to divide through by the square root of a. Before I do that, though, I want to remind myself something about a. What's a? A is a positive number. So I'm in complete right of doing that. All right, it's a non-zero number, complete right to do that. So now I'm on this line over here. And let me erase this up here. Now what do? I would square both sides to get rid of the radical. And so it's not bad, because 5 squared is just 25. And 25 times, that radical gets squared would just be y minus a. So I get 25y minus 25a. On the other side, I'd get 9, because 3 squared is 9, and the radical disappears. So you get 9y plus 9a. I'm starting to realize I can actually solve for y now. And how would I do that? I would subtract 9 from both sides, and I would get 16y. And I would add 25a to both sides, and you get 34a. What would I do now? I would divide both sides by 16. And so what would y equal? Let me write this down for you. Y would equal 34/16 of an a. So y is going to equal 17/8 of an a. I know what y is. Now certainly, y is certainly greater than a, because 17/8 is bigger than 1. All right? So I'm pretty happy about that, because I said so in the beginning, it should meet that condition. And the thing is, how do I get x? Well, I'll tell you, one way to get x is just plug it in right here. It might be tough, but I want to go through that with you. Right, so x is going to equal 17 quarters of an a plus, what's y equal to? 17/8 of an a plus 3 root a. All right, and then it's going to be this over here. It's going to get tough, by the way. So I have to do 17/8 of an a, which is y, plus a. All right, let's see if we can do it. And I'm going to go real slow with this. I'm going to just add the first two terms together. Calm down to be 8. sure I didn't make any mistakes over here. So 34 and 17. That's 51/8. Plus 3 root A. I'm going to factor out a root A from the other guy. And then I'm left off with 17/8 plus 8/8. 17 plus 8 is 25 eighths of an A. I'm not an A. What am I saying over there? I factored the A out. Eight eighths. Make sure I'm doing this right. Yeah, I think so. Let's keep going. Let's write this down. Square root of 25 is 5. And the bottom is going to be 2 root 2's. I'm going to multiply top and bottom by root 2. And you get x equals 51/8 of an A plus 15A root 2. And the bottom would be 4. Let me keep going. Call that of 8. 51A plus 30 root 2A. Let's take a look, see how we did. And what I mean by that, I know I got the y in the problem, all right? Sure, we'll look at the answer now. And did I get the y down? Yeah, it's right over here. And I want to see if I got the x right. And let's see, I think it's right over here, isn't it? It's a nasty number, though, isn't it? They factored out the A, by the way, 51. Yeah, we did okay. All right, by the way, I do go about checking these things, but, you know, it can make sense. You don't have time to check a lot of stuff. You're just happy to get to the end of a problem and hope you got it right. And, you know, some people are better at the others, but, you know, don't worry about where other people are. Worry about where you are. You want to move forward in that. All right? I realize sometimes people say, oh, I got a better way of doing things, and clearly there are better ways of doing things. I'm not saying I have a monopoly on the best way of doing something. I don't. Sometimes I have the weirdest ways to an end. And you might have a quicker way to the end. And that's a good thing to be sharing with other people, your quick ways to the end. Here's the deal, though. If you need to reach out to me and I'm not overwhelmed with emails, I'll entertain your thoughts. My email address is Bannon. That's B as in boy, the @ symbol, NNON.US. All right. Again, I want to remind you that it's, you know, sometimes when people are saying, gee, if I email this guy, is he ever going to get back to me? You know, these videos are not very popular, so it's rare to get an email from somebody. But that doesn't mean they can't become popular. Like if all of a sudden people are looking at these videos and I'm getting 100 emails a day, there's no way I could respond to them. But if I'm getting like 1 or 2 emails a week, yeah, I can respond to it. All right? Please feel free to email me. If I don't get back to you, don't be offended. All right? But I'll try my best to get back to you. Again, that's my email address. Thank you so much for paying attention. I do appreciate your time.